Hello, Bearcats. Okay, today we're going to have a discussion about long division and synthetic division. Both of these methods, both long division and synthetic division, are helpful when we are trying to graph polynomial functions of higher degree. They are helpful in factoring, reducing polynomials so that we can factor, and also in finding zeros. Let's take a look first at long division. Okay, in long division, we are given a polynomial, and this one happens to be in standard form with no missing terms. We have a squared term, a first degree term, and a constant, and we're dividing by x plus 1. We're going to set it up just like old-fashioned division. So we have x squared plus 3x plus 5, and we're going to divide by x plus 1. All right, what we have to think about is use the first term of our binomial. X times something. Okay, x times something, right, that's going to go right here, multiply together gives me x squared. That would be an x. So x times x is x squared. Then you also have to go x times the 1, which is x. Now, in old-fashioned division, remember, once you put things underneath, you subtracted them. So we're going to subtract both terms, so negative, negative, draw our line. If you do this correctly, this term should always cancel. We add straight down, 3x and a negative x is 2x plus 5. And then we go again. So x times something gives me positive 2x, so that would be plus 2. So 2 times x would be 2x, and 2 times 1 would be 2. And then remember, we must subtract, so subtract, subtract, draw a line, these cancel. 5 and negative 2 is 3, and 3 is our remainder. Okay, we're going to write our remainder, since it's positive, as plus 3 over x plus 1. Let's take a look at the different parts of this equation. We have x squared plus 3x plus 5 divided by x plus 1. Okay, this is the dividend, and this is the divisor. That was equal to x plus 2 plus 3 over x plus 1. This was the quotient, and this was the remainder. All right, go Bearcats. Let's take a look at synthetic division. Okay, there is a place for both, and actually when we get to rational functions, long division can help us find the equation of our our slant asymptote. So there is a reason and some for both, and one sometimes is more convenient than the other, depending on the information that you're given. So let's first take a look at something. Let's look at our dividend here. And notice we have an x to the 4th, an x squared. We're missing an x cubed. So we will have to put a 0 placeholder in our division. All right, and then we have an x to the 1st, and we have our constant. So that's the only thing missing. So we have to put a placeholder right in here. All right. X plus 3, we're going to divide by x plus 3. In synthetic division, we divide by the solution, oops, to the factor. And if we get a 0, then we know that factor is one of our zeros. So in this case, we'd be dividing by negative 3. That's really important. If we don't get a 0, then we know 3 is just an x value on our graph, and we will have the corresponding y value in a minute. So we'll have a point on our graph, we just won't have necessarily a 0 on our graph. So it gives you a lot of information. So if it equals 0 when you divide by the solution of the factor, then it actually was an x-intercept. All right, here we go. Let's set this up. So our synthetic division, we're going to use our coefficient. So we have a 1 coefficient here. We have to put a 0 in for our missing one. We have a negative 10 for our square term. We have a negative 2 for our x, and then we have a 4. And then we're going to do this synthetic division. All right, and we're going to divide by negative 3. Okay, in synthetic division, and if you need an extra row in there, you may use one, but I would try to get more proficient at it. So the first thing you do is whatever this first term is, it comes straight down. Then you multiply. 1 times negative 3 is negative 3. Negative 3 plus 0 would be negative 3. Then you multiply negative 3 times negative 3. That's a positive 9. A positive 9, if you need to write it in there, you can. And a negative 10 gives me a negative 1. A negative 1 times a negative 3 is a positive 3. And if you need to write it, you can. And negative 2 and a 3 is going to be a positive 1. And 1 times negative 3 is negative 3. And a 4 is a positive 1. So this is our remainder. So we could write it back. We've reduced from a 4th degree to a 3rd degree. So we could write our equation back now as 1x cubed minus 3x squared minus x plus 1 plus the remainder 1 over x plus 3. We could do that. We also know some other information. We know that we do not have a 0. We know that negative 3 is not a 0 of our function, but it is an ordered pair. So the ordered pair, negative 3, 1, would be a point on our graph, which would help us when we were graphing. So this is still important, and this is called the remainder theorem, and it gives you a point. So the remainder theorem gives you also points on the graph, as well as if that were no remainder, then you would have known you found a 0. All right, go Bearcats!